Well, hey again, everybody. This is Bob from Hot Rock Central, and originally I was going to do a video covering my entire solar automation system, but being there's so much involved with it, it would have made for a really tedious long video to make. That would have been difficult to do for me anyways. So what I'm going to do is I'm going to break this up into different sections, and today I'm going to be covering the heating and cooling of my battery cabinet and the hydrogen gas alarm system. And basically those are two separate systems, but during the summertime I have to make use of that fan there for both of them. So I had to come up with a way to combine the gas alarm circuit and the cooling of the battery cabinet into one circuit. So what I had to do was I had to take this thermostat here, which normally is tied in just to the heating pads, and I had to combine it with the gas alarm circuit. So I came up with a way to wire it up with this switch here, so I could separate the two or combine them. And during the summertime, it combines both the gas alarm and the thermostat, and when it reaches a certain temperature, the fan comes on and it draws the air conditioned air here out of the shed into the battery cabinet and keeps it cool. And at the same time, I still needed to have the gas alarm tied into the motor there, into the fan. So what happens now is during the summertime, the thermostat and the gas alarm systems are combined together. And basically what happens here is when the battery cabinet temperature reaches a certain level, the thermostat overrides the gas alarm circuit and just turns the fan on. And at that point, with the fan running, there's no longer a need for the gas alarm to be controlling the fan. So I have it so it overrides it. And then during the wintertime, what it does is basically it disconnects the thermostat from the gas alarm circuit, and it just uses the thermostat to feed electricity to the heating pads that are inside the cabinet. I already covered this in another video, but since this is relevant to the one I'm doing now, I'm going to go over this again. Down there at the very end, you'll see a white module sitting above the dryer vent, and that's the gas alarm sensor. And the air coming into the cabinet comes in from the shed through here. This feeds the head of the cabinet, and then the flow just goes straight across the cabinet out to the dryer vent. And then there's the outlets that I have in here for the heating pads, and there's 10 separate heating pads underneath these batteries here. Each one of them is 17.5 watts. So when it's activated, I'm using a total of 175 watts to heat up this cabinet. And as you can see, I've got plenty of battery power here, so 170 watts is really not much of an issue for this size battery bank. So anyways, I think that about covers this part of the system. Thanks for watching, and if you have any questions, just leave them down in the comments section, and I'll be back again soon with another part of the system. Thanks for watching. Well, hang in there, not quite finished yet. I just wanted to show you something else. As I ended the video and closed the lid on the battery cabinet, the temperature inside the battery cabinet was 97 degrees. And the outside temperature, which is that reading there, was 95 degrees. So it's been an hour now since the lid's been closed, and I just wanted to show you that the temperature dropped 9 degrees from what it was after I closed the lid. So it's showing that it's doing a pretty effective job of cooling down the battery cabinet. Now another thing is last year I had the batteries here on the floor in the shed, and I didn't have quite as many, so during that time I had them inside here. So it wasn't drawing any of the cold air out of the shed to cool the cabinet. And the 10,000 BTU unit that I had in here was running continuously all summer long during the day. It wouldn't shut down until sundown. So I figured I was going to need to beef up the air conditioning in here, being that I'm going to be drawing a substantial amount of cool air out of the shed and throwing it in the battery cabinet. So I moved up to a 15,000 BTU, and well, it's 85 degrees out now. It's not a real hot day. You know, the hot days around here get up to 100 degrees, and so it's shut down right now. But I expect probably even with this 15,000 BTU, it's probably going to run continuously too, now that it's also drawing cold air out of the shed and throwing it in the battery cabinet. And one of the other things is when I first got this thing up and running, the shed was completely uninsulated. So I found out that during the hottest days in the summer, there was a lot of heat coming in from the roof. So what I ended up having to do was paint the roof white, and that substantially reduced the heat off it. But it was still, you know, you could put your hand up there. You put your hand up there, and it was quite a bit hotter up there than it was down lower. So I insulated the roof, and that helped a lot too. But even still, with all that, the 10,000 BTU would still run continuously. Now, I fully expect this is probably going to run continuously too when it gets up to 100 degrees, but that's okay. At least it'll be cooler in here than it would be if I had a 10,000 BTU. So anyways, that's just an amendment I wanted to add to this I thought you might find interesting. And I'll see y'all later.